Okay, so during the last lecture we were working on our network demo and we didn't manage to really finish it. So as you remember, we can start various processes that do various things, but we don't have any built-in overview of which processes are running and which are not. So we will want to do this now. We can open our UI file again so that we remember what we want. So our goal is that when we start processes here with the buttons, so that they will be rendered in this list, and if they would terminate, that they will be removed from that list. To this end, we have implemented this start process function, which will work as a helper. So it's called by all the buttons, just with different arguments, and it starts our process. We forgot to add the return value, so we should quickly add here, or actually we could also remove it and not return anything, since we are not evaluating the return value anywhere, but let's leave it as is. That is, I think, more user-friendly. And the way it works is it creates a process object. It adds this object to our map, to our set actually, since we don't yet hold any per process data that couldn't be retrieved from the process directly. And here we are just spawning that process. As we can see here, we don't have many options that we could set. Directly on the queueProcess object, it's a bit minimalistic. If you would really want to do some more advanced things, it can be supplied with a handle that you have created with create process using the Windows's built-in process creation feature, or with a handle that you could create on some other platform. But then, of course, you would need to make your code aware of all the platforms on which it is supposed to run. So it's if you can make it work just with the standard features, that's of course the more advisable option. So we will want to connect a few signals and slots, most importantly the one that is fired when the process finishes. We can also, by the way, add here a check if is state, and there are a few states it can be in. It's annoying that doesn't lead us to the states. Process state can be not running, starting, and running. So not running, obviously it's not running, running is running, and starting is like an intermediate state. So we can check if this is here, if this is equals q says not running, then it means something went very wrong. Then we just return false without queuing the thing here. If it's something else like starting or even running, then it's fine, and we can continue. In principle, we could go for two signals. When we look again here, we have where is it? Signals. We have started, finished, and state change. So of course the most universal option would be to go for this state changed. But going, for example, for finished would also be good enough. I think for our use case, just finished should be fine. So, and we will of course need a slot to connect to, so private slots void on process state change. Or on process change state. We don't want this to be too long. And large O, so that it is nicer. We will just add it here close to where we need it. Snack. Okay. So we have our on process stage, and now we need to connect it. I prefer to using the modern connect style, where you specify the things like this, because it's kind of a bit more reliable, in my opinion. This you know directly to compile time if you have specified it correctly, instead of waiting and seeing if something happened that you didn't want. By the way, we need to we care for the exit code status. We don't really care for those information. So it can be as is. This is the sender queue object cast sender and huh? Queue object class, that seems fine. Process usually should use an access. Why is it complaining? We have sender. What have we broken here? Networking object should be fine. From overload function, what the fuck? But we had this included, that should be existing in the header. Where is it at? Yes, this is correct. Something is broken. With the simple way it works fine. Object. Here it doesn't like this. That thing won't save. Sure. The round brackets. Right. So if this is repeated, then we just return. This should never happen, but it's good to have such sanity checks in case something unexpected happens. For now, we just put a breakpoint here and see if this works so far. So we open here a server, which worked, and then we will terminate it, and we get here into the slot when it was terminated. It might be interesting to check the behavior if we try to start something invalid. We can easily break it by just adding here some invalid string to the path, and it should not be able to start the process. And here then it fails direct instantly, so I think we will not run in any intermittent scenario. So either it can create the process because the file exists, or it cannot. It should not like here be fine, but then never trigger this finished, because even if it crashes, it still counts as finished. So only if it would not be created in the first place, then this would not be fired. So that should work fine. Let's make it a bit more compact. Okay, and then what we want, of course, is to remove the process from our set. So at this point, of course, it is not yet quite ideal, and now we have to decide how we want this to operate. We can either synchronize the set with the tree in our timer. That is option 1. Option 2 is that we just call an update whenever we know that something changes. And generally, such timer-driven actualizations are only reasonable if you are expecting if you're expecting generally that each time the timer runs, there actually will be something to change. For example, if you would have a lot of processes and you can say at least a few of them will change in the time between the timer intervals, then instead of redrawing the UI each time again and again very fast, it's better to do it on a timer, because then you can do it slower. You could also do it in a bit more complicated way. Whenever something changes that actually needs attention, this will set a flag, and then during the next tick of the timer, an update will be performed. And since this is the most recommended solution, we will also go with this approach ourselves. and usually you refer to the information as being dirty if it's not synchronized with something. I don't know for what reason people selected this nomenclature, but they did. So we will stick to it. Whenever we remove or add something to our list, we set the flag. And then in our timer, we just, if this flag is not set, then return. If it is set, then we reset it. And then, of course, we need to proceed to process it. And as you may remember here, we have added this tree widget instead of tree view, meaning this thing manages all the data model for us automatically. So we only need to somehow update the internal data model. And an efficient way of doing so is to have a helper list of the old data that are inside of your model. This can be either remembered or it can be generated on the fly. So let's well, that will be a set q set of int32 all processes for int is equal 0 is less than. Now we need to remember how do we call that thing. It's called tree widget. It's boring. Process tree. And no, we don't write the whole word. Oh, maybe we can either abbreviate and just call it proc tree or give the full name process tree. But since we everywhere else used the full name, then let's do this here as well. y.process tree top level item count. As mentioned during the last lecture, this control in fact can show full hierarchical data like a tree view of Windows Explorer. But if you just want something that looks like this control, you can also use this view. You just don't add any child items. You keep everything on the top level. And there is even a setting that you can get rid of the indentation to make it look better. And unfortunately, Qt does not have a flat multi-column list. It only has a single column list or a full table. And the full table is for other reasons not ideal, because it has also a header for every row. And that could of course be hidden, but the way it's graphically rendered, it looks more like an Excel sheet than a list just with multiple rows. So optically I really prefer using this tree item. Okay, so we have this item, then we need to go through all the items. So top level, what was it, child item, child at, I think, no, that's not correct. Top level item, yeah, that's the right one, from index I. That gives us a Qt widget item per item. Okay, and this thing, now in this thing we can address every every cell for every column entry. So we can get text using the function text, which then just takes here a column ID, and with every of these cells is associated also a data object, which we can then set or retrieve per column. Here we do column 0, role is Qt user role. There are other roles defined which would have an effect on how it is rendered, etc. So if you see here all the roles, we could set a tooltip, we could change colors, etc., etc. But we just want some data that we have defined ourselves, which is this user role. And this is a qvariant, so to uint. And this is our uint32 pid process ID of the process for which this row belongs to. We haven't set it yet, but we will. And in this old process thingy, there should be a map, qmap. It contains these things, old processes. We just insert at the position of the PID the actual object, so that we can then easily retrieve it. The thing is, we cannot search efficiently inside this tree for an object by a provided user role value. So here we basically make a cache of values we only have to go once through the whole list, and then we can retrieve data from the map in a very efficient manner. So the map has a lookup time of order of log n. So if you double the amount of elements in the map, the amount of comparison operations only increases by 1. So it can grow hugely, and your complexity of retrieving one value won't really grow that much. So now we want a for each loop. As you might remember, this is something that only Qt offers. It's not an actual C++ keyword. It's just implemented manually in form of a loop. So it's quite nice, and it gives us the opportunity to just very nicely go through every entry that we have. So here we are going through every process, and we already have the process here exposed, so we just want the PID int 32. PID is equals process process ID here. Process IDs are a concept that exists pretty much on any operating system that has processes. So whether you have Linux, Windows, Mac OS, or other more exotic operating systems, you basically always need some way to refer to a process, some way that is globally unique, and this is the process ID. In the case of Windows, you have also process handles, but a handle is always only valid in the context of a given process. So if you have a handle value that was valid for one process, in your process it won't be valid, and if you would to open the same process by the PID, you would still get another handle value inside your own process. So these PIDs are quite important. And when we have it, then we can just see if this process is already listed in our list. So we just want to retrieve the element. So, alt process, and this is where Qt is so nice. It is a function take, which looks up something, takes it, removes it from the map, and returns us the value, or it returns us an empty object created with a default constructor if nothing was found. With STL, you would need to write a couple lines of code to get this functionality. Of course, you could just write a map underscore take function of your own that would do the exact same thing, but there's always additional overhead. So with Qt, if you are starting a new project, it's really nice that you can do such things. And here we now check if this is null, meaning this entry basically didn't exist yet. Then we just create it. Oops. And once we're done with it, we will have to add it to our tree. Top level item. As you may have seen, there is also add top level items, like plural. And if you would expect that you would add a lot of elements, then it would give you a better performance to cache the new elements in the list and then trigger the add top level items once, because this reduces the amount of times the tree is recreated and redrawn. Here, each time you add one element, the whole thing will be, at least the displayed portion of it will be redrawn if it falls in this range. So if we would have many of them, it would be a better approach to do that differently. And now we set data, null, comma, Qt user role. And we have a third parameter, which is the actual value. So here the process ID, and then we can also use the opportunity to set text. And we should check again what we have. So we have the task name, we have the process ID, and we have the command line. We want all of them. We don't really need all of them. We can get rid of the task. We'll just keep process ID and command line. That should be good enough. And so that we can refer to them easily, what I always do is I go into the header of the relevant class and then define an enum. Columns. Of course, it's the easiest if you only have one tree element. PID 0. And it will automatically count through them. So if I change then something in the tree itself, then I just remove right here an element and all the values get adapted. This is quite convenient. In principle here we could, instead of 0, use pid already, and here as well, and text pid is q string number. So the number will be just a text representation of the number here, so this is easy. And then we want of course to set also the command line. Command line, comma, and the command line we can retrieve from this. Was it arguments? It was arguments, comma, join with a space. And in principle here we could open that which may change, which in this particular case we don't have, but if we would have something like uptime or well something that we want to update, then we could do this here. Of course then we would need to reset this flag on the other events that are relevant. And the way this works here is that all the elements that we have copied here into the map will be removed out of the map if they are found, as new ones will be created. So at this point, after the loop, the only elements remaining in our old processes map are elements which have been removed and which are no longer present inside of our set. So we can just go through all of them and just delete them. And the tree widget items are linked to their parent control, so that if you delete them, they are automatically removed from the control. So you don't need to manually remove them first and then delete. This will happen automatically. So let's try this out. Run it. Then we start the server, and voila, we have a server running. And as soon as we, let's put this here, terminate it, then it disappears from here. So we can also start the client. Client is doing something, and then we kill the client, but the server is still there. So let's set another client. This time let's try killing the server. Both go away, so this works quite nicely. And what we could do is here we could extend this with some mechanism that would, for example, count the amount of packets or data sent or received by the individual things that we have started. So let's quickly add this. So we go again to our UI. We already have the command line. Let's again add sent and received. You could also go for maybe just one column saying status, and then yeah, that might be actually nice. Let's go with that. We just call it status, and then we can make this status display whatever we want, and we will make status the last column since it also might be quite long. So here we go to this thing. We only need to add status. If we would have added it in between, we would just add it here, and that would automatically adapt the offset. So this is why this method with this enum is so nice. And what we will want, what we would need to do this with the status would be somehow to communicate data back from our clients. That might of course complicate things. That would complicate things a lot. So I think to not make this sample too complicated, we maybe actually don't do that, because this would add the additional complexity to add inter-process communication to every single child process and then communicate data back. So I think instead of doing this, we'll start just a second sample, which will be made in a way that will allow us to play with this tree nice and don't have to make this more convoluted communication schemes. I don't think that would be. I'm thinking we might add here really this inter-process communication, so that all the clients always report back to the client that spawned them. But would you be interested in such a feature in this example, or would you prefer to see another example being implemented now that would showcase another mechanism? Okay. No. Another example. Okay. Then let's start with that. So create a new project. Create new project. Widget application. Let's call it data panel. Not quite right. I didn't select the precompiled header. That's usually good to have. Let's recreate it again. New project. Widget. Okay. Enable PCH support. That's the right thing. Now it should be fine. So in this example, we'll do it slightly differently. So we will add a list of plugins which exist inside the same process. So the communication is much simpler. And those plugins, initially we will just hardcode them, but later on we will make them reside in own DLLs. So this will showcase, like the previous example showcased how you start processes, and you have there all the tools needed for inter-process communication. Just we didn't add additional inter-process communication for status purposes, but you could just use this local server and local client to implement the communication between all the children and the controller. That would be easy. Here it's different because everything resides in the same process, so the communication is much more direct, and also the way the components can be integrated is much tighter. The level of this integration, of course, depends on the level of interoperability that you want later on. So with processes, the nice thing is that as long as you don't change the protocol, nothing will break. You can just update the processes, change them, etc., etc. With plugins, with binary plugins, basically with code that is loaded into another process, this is a significantly more complicated approach, because there the entire API needs to remain stable, and this is something where people might be more prone to changing this for reasons of improving things, of adding functionality with just a protocol. Usually the protocol from the communication protocol from its design is made extendable in an easy way. With APIs this is not always the case, and if you do it, then there is quite a set of rules that you need to obey in order to ensure compatibility. And on the other hand, if you don't, and then just add, you cannot just add an additional parameter. You would need to make a new version of the function, which then takes this additional parameter. So it adds overhead, and thus people might be prone to just break compatibility more often. So we will make this panel here slightly differently. So in the previous example, as you remember, we used still these UI files to create the interface. Here the compiler created some for us, but we will not be using it. We will be just let's delete that, and we'll be creating the whole interface manually. So this also goes away. Creating this manually is quite easy. It's not very complicated, and it gives you much more control. So I think it's good to have done this like this as an exercise. First we need the main widget, and then we need also a layout queue, then mpan main layout. Let's wire it in. Yeah, this thing goes away. Data panel. This set central widget. Oops. This thingy. Okay. And we will need a few things in our panel. So we will add a QWT view, a plot, so that we can plot data that we receive from the plugins. And we will add a list of plugins, a tree that contains all of them. And what else we might add, we can then add later. So for starters, we won't be adding the QWT plot, because that will be something that we will add later. For now, we just create a Q3 widget. That thing might need to be included first. And Q. The layout as well. Okay, so we have this and let's call it plugin tree. For now, well, and we will need a few things. We need a way to load plugins or remove them. We could either add a toolbar directly to this thing, or we could make a small layout with individual buttons. I think the toolbar is the more generic approach, so let's go with that. Q toolbar plugin bar, and we should set everything to null ptr here, just for good measure, and the toolbar again will not be yet included, so we need to add that. Okay, toolbar. Okay, so in this create those two new elements. Set header labels. This takes a queue list, and an easy way to make a queue list is just to start with a string and then split it. But for now we will only have one, or maybe two, name and type. Name and type, then we will define this here for later. Enum plugin columns, name equals 0, type gets out value automatically. Semicolon, and we have our grid layout. So and we'll save here in which column we are working, so that if we want later to add the plot on the left hand side of the thingy, we just change this from 0 to 1. That will make things easy. And we add another helper variable, int row is equals 0. So my layout, add widget, takes a widget that will be our toolbar first, and here we can set the row. So row is row plus plus, a column is plugin column, and this span would allow us to let it span multiple cells inside this grid. For now we don't need that, so we will leave it out, but we might need this later. And here, since row is auto incremented, we can then add the tree. Actually, we could keep the tree at the top and the row and the plugins at the bottom. That might look nicer. We also need to add some buttons to the toolbar. It's a bit boring without buttons. So add action, and this is quite a powerful function because it takes quite a few arguments, and it allows us to connect things directly from here with the right slots. So what would we want? We would need an add plugin and remove plugin, I guess. add. We don't need to write plugin because that's self-explanatory. We don't have an icon. We don't need a key sequence. Just have a receiver, which is this, and a member slot. On add plugin, which we need to add later, and of course we want to remove. On remove plugin, data panel, private slots, right? On add plugin and on remove plugin. Zack, zack. So they should be triggered when we press the button. Let's run it to see if it works fine. The first compile always takes a bit longer, and we have here the thing, and here we have our buttons. If we press one of them, we end up where we want. There are a few things I here kinda don't like. The spaces are a bit excessive, so we can change this. As well as the content margins, these also don't look ideal. Set content margins to 3 and set spacing to 1. Set spacing to 1. This changes the way it looks a little bit. So you see here now there is much less edge on the edge, and the buttons are a bit closer to the actual thing. Okay, so that's like the very most basic things. What we would also want is an ability to interact with the plugins, maybe some additional functions. So a context menu would be a nice thing to have. So this can be added quite easily. Here, Q menu and working menu is equals null ptr. Okay, and this thingy we just we have created a tree here, so we can create it here. New menu. Set context menu policy. What do we need to set this to? I think to custom qt custom menu, and then we need to make a slot for it to open the menu. Void on plugin menu, so we call it always related to the tree, because in case we add another tree, we don't want to have like just on menu and then we don't know what menu this thing belongs to. Connect plugin tree, comma, add custom menu requested, comma this, comma data panel. Okay, and menu here, pop-up, cursor position, so we want to open it at the current position, and here we have the opportunity to enable, disable, or even hide entries. Of course we don't have any entries yet, so let's add some. So we have the menu here, and in principle we can just use the same add action mechanism from here. Just need to change this, and then here we would want to change this such that if we don't have anything selected, that then the remove will be grayed out. So we need to track this thingy. So in order to be able to track it, we'll add here action q action, then mp plugin menu, add and remove. Add we don't need yet, but it's nice to make those thingies a bit consistent. So add is this one. The nice thing is that the add action already returns you a pointer to the action that was just created, so it really is optimized to save lines and don't have to write too much code. So Qt will reject items, and item is gleich tree current item, and if this is null, oops, if this is null, then remove set enabled false. Actually, we can make it differently, even better. If this is null, then it's false, and if so, actually we just wanted this, okay, null ptr. So if it's not null, then it's true, then it's enabled, and if it's null, then this is false, and then enable is false. The add button will always work, since it does not need anything, and in the end it will end up in the same dispatch slots. So if we want to add something, we always add it, we don't care what is selected, and if we want to remove something, we should, since we might arrive here from the button, make a sanity check. So if this is not, then return to do. Let's run it. Will be a bit boring, but we already have the menu. As we see, one gets disabled. So now we will need to add a plugin, but before we can add a plugin, we need some sort of plugin. So we should create one. So let's switch here to this folder view that will allow us to structure things more nicely. Add folder plugins. Add class wizard. That's too complicated. Let's just do it manually. This one is easier. Yeah, we will need a C device or C plugin, maybe. C plugin, which will be just in plugin 8, so that will be an abstract representation of a plugin. We will set as base class QObject, since we will want these things to be able to work with signals and slots and all those nice features. Zack. This was created not where we wanted, but we will just quickly move it. Okay, and what we'll also need inside our plugin will be some means of creating new instances of different plugins. So when we are not working with a DLL, then this is quite let's say straightforward, because we can just use new. But if we are using DLLs and want to make this significantly more sophisticated, then what we'll need is we'll need some way how we can create an object from within some other DLL, and in a way that it will make this as universal as possible. So here for our use case, we'll use a factory class, so something that allows us to create a plugin and always has the same interface. So no matter which plugin you create, it will always have the same interface, but you will be able to call the different instances of this factory thingy. So class plugin factory. And this thing we will not derive from QObject, we don't want that. What we also should add here, since we want to be fancy, we will add a type def for a Q pointer. This probably needs to be included here as well. Hash include. It's always a bit a guesswork what do you need to actually explicitly include and what already was included inside of one of the other includes. So yeah, and this will be from our C plugin, and we will call this type C plugin PTR. So we can always use this type instead of writing this whole thing to have a smart pointer that will reference count our plugins, and once the last instance of the thing goes out of scope, it will get rid of our plugin. Okay, so for the plugin itself, we will of course need the QObject macro, and public we will need a constructor plugin QObject stamp gleich PTR, so we have a constructor, and abstract destructor is already part of the QObject, so this is fine. We'll add an initializer function. And this function will later get some things, and it's a virtual function, so on the plugin itself it's not implemented, it will only be implemented on the things derived from it. And then we also want a QString get name const, which we'll implement here. String with a string or name, name, let's call it name. Name, and we want also a set const reference name const name is equals name QString name. Okay, and we can add later more functions to the thing depending on what functionality we want there to be. Good. So now this factory class, this thing will also be something that we want to be able to create, but it doesn't need to have anything particularly interesting in the constructor. And the destructor, oops. Right, then we will be making such functions derived from this thingy, classes derived from this thingy that will be able to create objects. So it will need, of course, a make function. So virtual pointer make, and this thing is again a virtual function because only the specialized implementations will actually create something. Then what we would also want is some general means of retrieving informations about this particular factory, since we might have many. It will be a name const null, and we could also add some identifier or something, but I think for now let's just stick with the name. The rest should not be necessary. So now what we create will be some test plugin, create class, demo plugin, and base class is C plugin. Zack. Okay. This includes plugin, this includes this. We will also need the same thing for the factory. Uh, plugin factory, demo plugin factory. Okay, the plugin of course again should get this standard thingies. So we forgot to add somebody for this function. Zack object parent radio. This is for now very simple. We could add more functionality to it, and for now we are still doing everything in one process. So we will be moving to put this into a DLL later on. Okay, plugin age, where is like missing and include somewhere. Yeah, object was not. I mean, object was almost certainly be included inside the widget thingy, but just for good, oops, for good measures, let's add this and let's see if it will complain about something. It needs some time to compile. Oh yes, this is wrong. Yeah, good. So now we need to continue on our factory. So when we look to our plugin here, we had a few virtual functions which were not yet, did not yet have a body. Right, we cannot use Terra because we are not inside of a queue object, but we can borrow the Terra from another queue object, and here we will call it demo login. And make is then of course actually that's also a const thing. Const return demo plugin, new demo plugin, semicolon. No, that needs to be wrapped in such a thingy. So if you, you can either do it like this. Demo plugin, that should be fine. Why is it complaining? It's missing something. We have not defined the init function. This one is missing. Override. Well, the init function the init function doesn't need to do anything. We could also, I think there is like a, oops. Is there a create? Yeah, create. So we can also do it like this. This create will just call new, and if there would be any arguments, it would pass them along. And it's less code to use it, to write it like this. So let's do that. Right, so now we could create at least one plugin. Let's make a second one, but now let's be lazy and just copy it. Data panel, plugin, demo plugin, and as you remember, we had some troubles when copying stuff around this other view, so we'll call this a test plugin before we move the files where we want them, so that Visual Studio doesn't get confused. Okay, Zack. Didn't. Now it loaded it, but it didn't make it. Great. Test plugin, factory. I think we need to switch to this view and then drop this into the project so that it's included. we are missing something. What did we forget? So plugin has just the init, the abstract thingy. Virtual. Alright, and this we have here in the demo plugin. It was also in this test. We forgot it in the test plugin. Oops, this would be just plugin factory build. What is this complaining? Which function is it missing? Plugin init is abstract. Yes, it is. Do we have a mistake somewhere? Oh, I know what the problem is. Here, we wanted to be smart and use this pointer, but the pointer only points to the plugin itself, but not to the constructor of this derived object. So we actually need to keep it this way for the thing to work properly. Also, I see we have not copied this here, and there, of course, this will be changed to test plugin. Okay. What did we forget here? That looks like a Visual Studio problem. Data plugin test plugin data plugin. I will remove that without deleting it and then re-add it, because I think it did not create the mock files. But it still didn't create the mock files. But this is set correctly. So what did we miss? For plugin itself, also that should be correct. We forgot something. We forgot the constructors for our plugins. Test plugin. Zack. And here we need to, of course, include the right thingy. Okay, and we wanted to, I want to return a value and on true, so to indicate that the init function worked fine. Zack. Good. So these basics are there. So what we will now want to create will be some sort of thing that will manage those plugins, so that we can have a nice list of them and create new ones and add them, etc., etc. So for this we'll create another Q object, a C plugin manager. Let's keep it at the root level. Q object. Zack. Okay, this can go. Public plugin manager. Let's not forget to make a constructor for it. Okay, good. And the plugin manager will have a few things. A map of factories, Q map. the string. We need to include the thing. Hash include. Plugin. Plugins. Plugin. It's plugin factor, capital P. And as key, we will just use the name of the factory that it will provide us. We could also generate some more unique ID, for example, but I think here just using the names is good enough. Although, let's think about it. Is it though? Because the name is localized. That might not be ideal. So let's also add a string ID. Get ID. It will be just as like the name, just without the tr. Public. And the constructor should also exist. Get ID. And maybe we don't need to add. Yeah, doesn't matter. Let's leave it as is. So the idea is that if one would make some translation of the for the thing, then of course the name returned would change. But if we have some code that relies on the name, then that will no longer work. So we also have an untranslated version of which we use as an ID. Right, so we have here our factory, and then of course we'll have a QList or QSet. Let's keep it with a list. So a set would be more efficient to delete elements from and to add elements to, but it would not maintain an order. And I think we want to keep the plugins in the order in which they have been added. So let's use a list. It's plugin ptr plugins. Okay. And now what we'll need is to populate our factory. So in the constructor, we'll just include all the things. Hash plugins, demo plugin and test plugin. Later we'll move those things around into DLLs, but for now let's keep everything in one place. It's a demo plugin factory, demo factory is equals new, and here insert get ID and the thing itself, and repeat the same thing for test. Then we will the ability to get the list. So sorry, get the map stack. Get const return factory, and this, remember, Qt uses a copy on write, so usually this will be quite efficient. We might also want to be able to get one particular factory by ID. Const funct value ID. Yeah, and then we would also want to add some plugin. Add plugin const plugin ptr plugin, and we would want to have a list of plugins. List get plugins const return plugins, and we need to take care of finding some nice tasks for homework already. So void and plugins. Do we need that? No, we don't need that. We just use the get list. We will just have them in the list. So here we'll also have a remove plugin. You can do it by point, and those two functions will need to go here. Right, yo. So this thing you will need to live somewhere. We go to our data panel header, include it, and so. Right, so it's plugin plugin manager is equals now ptr, and this thing will create a new instance of. Okay, so this thing lives here, and we will need now some means of adding this, some of the plugins at least, and I think for this a nice add plugin window would be useful. So we will just create add a new class, say add plugin window, and we derive this from dialog. Suck. I'm not sure if we have that included, so let's add this to our standard header, that we definitely have it. And the dialog, since it's a Qt object, will have, of course, first a few Qt things. Q object public, and then needs a constructor. Q will get stern parent ptr cute. And we will want so the way is when we want to add a new plugin, we will create a new instance of this thingy. It will show to us a list of plugins that we can create, offer us the option to give a name to the plugin, and that's that. So we will need, and of course if we cancel out from this dialog, this also needs to be somehow notified. So what we'll do is we'll just have a two functions that will return one, the factory that was selected, or null if none, respectively if the user cancelled, and one that returns a name if a name was set. So class plugin factory, let's just get factory string get name, or new name, get new name. Return new. Actually, this we can return directly from an element that we'll create in a second. Private, and here we'll have qvbox layout. Main layout. Null ptr vbox. Yeah, that's up down. Then we have a combo box, q combo box stern mp plugins. and q inedit pen new name, and from new name we just directly get text. And we need some q log button box pen buttons. Those things might not be included, so let's just add all of them. Qt provides an include file for pretty much every single object that it has, so it's quite easy to include the right thingies. So we have this, we have that. Now we need to create it. We'll grab the constructor. What was it? Q dialog parent. Okay, and now we'll copy those thingies so that we have them. New this. Then this. That layout. It's quite peculiar that some of the Qt window types, like QDialog, have this set layout, and you just set a layout, while the QMain main window, like here, actually needs this set widget, and you need to have an explicitly created widget object. So these dialogs are a bit more convenient. They just simplifies this slightly. Okay, so we have our set the things, and now we just put things into it. So we need, of course, the combo box, which we need to populate. We will need also the line edit. Okay, and we have our layout. So that widget, turn, select QLabel new Q add widget plugin, set name, yeah, and our button bar. Oops. And with the button bar we need to define what we want it to have. So QDialog button bar, button box, cancel, and the other thing we want is OK, I guess. So we can look what all we have to display. We have no button, which is kind of no button. We have OK, save all, open, yes to all, no, etc, etc. We could also create custom buttons, but for our use case, let's just go with those standard ones, and we will need to connect a few things. We should also add here a slot. Private slot on plugin and index slots plugin void, and this will be set to fire whenever we change something in the drop-down box. So combo box is here. Connect combo box q combo box and index what was it? Comment box. Current index changed. Yeah, that was this. Reference, comma, is on plugin. And the button box, so here we put a breakpoint, and the button box will also need some connections. Connect. Button box, comma, accepted. Let's submit this. Accept. Rejected. This will handle the OK and cancel behavior, that if we press the buttons it automatically closes the dialog. And here well, we need a few more things. We need to populate our Dingsta Boomsta, the whole thing. And we need some way to address the device manager. Otherwise, that of course gets complicated. So let's add here in our data panel a function to do so. Plugin manager. Just plugin manager. Return plugin manager. And data panel. Data panel. So we will create a global variable, which will always point to us wherever we are. Or to nothing if we have gone out of scope. So now inside our add plugin function we can just plugin manager. We also need to include the plugin manager, by the way. It's already included. Then we don't need to include it. Then it's fine. Plugin manager get factories. That was what? That was a map. It doesn't matter. So plugin factory. Okay, then plugins, add item factory, get name, comma, factory get ID. So here we can associate with every entry a Q variant, which can be any of the different Qt types, which is quite convenient. Okay, so here in this function, when the index changes, we will just now grab the index. We have our Dingsta Boomsta plugins. Current data to string qstring ID, and now we want to grab the factory. Factory is on this. Actually, we can simplify it a lot. We will need that later, but we can make it simpler. We just want a new name. Set text. We can here just go with grabbing the current text. and we add, let's say, Tara. Okay, we just whenever we select a new plugin, the name will be automatically set to new and then the name of the plugin. Okay, and the last thing we need, we need the things we put in the clipboard and this get factory. Zack. Everything set item set data, yeah. Current data, this is missing here. Current data, yeah. ID factory from ID. Oops. Get factory by ID, and you can just return this. Okay, easy enough. So now we will go to our panel here to the add plugin button, and there we will use our thingy. So first we need to include it. Include add plugin vendor. Go to add. It's add plugin vendor. And this. Oops. Window.exec that shows it in the model way, and if and so it blocks until we press OK or cancel, and if we press cancel or close it, then this will return 0. So then we just return here as well. So only if the user pressed on OK, we will continue. And if they did so, then we can get the factory. It's plugin factory equals this. Then a quick sanity check if this is something, because if it's not, then return. Yeah, and if it is something, then it's a plugin factory. Plugin is equals plugin factory make. Plugin set name. In principle, you could check whether this was successful, but I think we can assume it will. B get name and plugin manager add plugin. Plugin, zack. Yo, that's that. It's added. And then we of course will need to update the tree. But here we will also do this with a timer. So ball so this true. Then we need our timer, so we can steal it from here. We need this, and we need that, and we need this. Actually, that much we could even take, and that. Zack. Data panel, protected. Data panel. Kill timer. Start timer. Okay. Plugins item. Actually, we can even copy a bit more. This thing we will be able to reuse. Just that we have a different plugin plugin tree. And here we will use something else as an ID. Int64. We'll be using the pointer or the plugins. We'll be using the pointer value as key. Plugin tree name. A name is the first column. This is not quite right. Long. Why doesn't this like this? Because here is the semicolon missing. Okay, and this is plugins, which here we handle the same way. But here, of course, this is different. Plugin footer const fence per plugin per plugin manager get plugins Int64 ID is equals plugin punct data. That gives us the raw pointer, and then we need to cast it on an integer. Alt plugins item wait, it's also wrong. It should be just ID. It would work, just not elegant. Right, name ID. Actually, the name could change. We probably would want to be able to rename the plugin. So here we will update the name each time. Plugin. Get name. This we don't have yet. What did we have? We had name and type. We don't care for type for now. Let's just only give name. Good. Then our add should already work. Zack. Here I forgot the end symbols. And we want to... Okay, we crashed. Why? Because this is still null. On plugin apparently gets triggered while we here while we are populating the thing, so we need to move it down somewhere where all the objects will already exist. That much could have been guessed. So if we change the plugin, the name automatically changes. So let's say demo plugin, my demo plugin, and okay. It didn't work. Right, I think the function doesn't have a body yet. Two things. First of all, here I would like to add a space so that the name is more name-like and not so much machine-like. And then the plugin manager, add plugin. We forgot to make it plugin to something. Quick fix punct append plugin, and just for sanity we could make a check if contains plugin, then return. Remove plugin will be a to-do. Let's just do it again. Add demo plugin, my demo plugin, Zack. Oh, that's a mistake. Well, yeah, we have not done any updates here, so it was fine, but technically what we were supposed to do is to have to change the the variable outside of the scope so that we can access it later on. Okay, but this time so close. New, oops, nicht new, my. Yeah, and we could remove it, but that will not do anything since we don't have a remove function, which brings us to the first homework. Yeah. The 30, 10 to 0 to 5. The panel things and the plugin manager, remove plugin, zack. Oops. Yes. Option. So, plugin. So it should just ask you, do you want to remove the plugin such and such? And if you say no, then it should do nothing. Other than that, it should just remove it. So I think this is reasonably easy. Of course, at the very end, we also set the flag here to dirty, so that it gets removed if it was changed. Okay, good. Any questions? Okay. Good. So if we don't have any questions, then we can proceed with the next part of the implementation. So we could add, of course, many things to this. For example, we could add initial parameters to our add plugin window function so that we can in fact set some values, but I think this would be rather more something for later. Since we said that we want to add a QWT plot, then we of course need some way to get data from the plugin, data that the plugin would then display. So we could now extend our plugin definition with some means that allow us to get said informations. So let's go to our plugin header, and so we have the name. We probably want to be able to have more than one channel of data per plugin. So for example, if we have a plugin that handles communication with an oscilloscope, that oscilloscope will usually have 2 or 4 or even more channels, depending on the type. So we would need a int get channel count const, and this thing let's make it return 0 instantly, because we might have a plugin that has 0 channels, something that is used to control some hardware just by enabling or disabling something, or that gives you other data. So not every plugin will be expected to have a channel count greater than 0. So as a convenience feature, we can add to our plugin definition this pre-implemented function. Then of course the next thing would be we would want a channel name, qstring get channel name const. This will just return an empty string, and it of course needs a int id or index, maybe index. Yeah. But here of course it's empty. And then we will also need some way to get the data from this thingy for each channel. So virtual q vector, zack, double, get time samples, and get small e, and get data samples. So as you might remember from before, the QWT library takes an array of x and y values, so two arrays, and then plots it on its own. So we will here want to do it, and we, for simplicity, will wrap it in a QVector, because here we can get to that internal data very easily, but the QVector will guard the objects, the object, and make the reference counting for us. So it will be quite a convenient approach to do so. And in principle, since usually measurements get stopped and started and so on, we would need some start and stop or ball functions. And this, I guess every plugin needs to be started. And it can return an error. Stop does not, although let's make it, let's give default implementations because some plugins might be made such that they just always exist. Could add a reset. True. And what we also could do, if we want to make the whole thing a bit more elaborate, we could define as some standard values for return values. So if you would want to not just return true or false on success or error, but kind of say what went wrong, we could define as here a header file, plugin codes h, for example, which we will include in our plugin h. And we can define hash define my no error is 0, let's say. Then what would be a good error? My error, or maybe let's call it plugin no error, plugin error, or plugin okay. That's nice. Plugin okay, plugin error. Not implemented is a typical error that we might want to would be already running. If we press start while it was already start, the other thing would be of course not running. Yeah, for the start this is enough, and then maybe some positive sort of error, like error finished with errors, which kind of means it was okay, but something happened that wasn't great. We can then define, of course, more codes, and here hash define is okay, or is success x. So basically, if something is less than 0, then we bug out. If it's 0 or more, then we say it's fine. Yeah. And this means we could change here on this to an int, and this, and why that as well. And here by default we'll just add plugin okay to all of them, since I think the way we define this not expect many issues. So of course we'll need to add some sort of start and stop button or something like that later on, that we can start and or stop a measurement. This will allow us to get the data which we'll need to add. So now what we could do is to add the QWT library. So we go to QWT test. We see where this was put. QWT test. We just copy the whole thing into our thingy so that we have a local copy on hand. Cute. When I will upload this to Moodle, I will just upload only those two. So this QWT you will need to add yourself from the other example. Data panel QWTs QWT project. And wait, that was not the right thing to do. We wanted to add it here. Add existing project. Test panel QWT source oops QWT project. Yeah. So now we have this thing added here. This is nice enough. So we will just go to our data panel. So we want data panel H, and here we will add. Let's say here's a good place. That will be Dingsda star class. QVT plot asterisk mp plot is correct nullPTR, of course, since we want to for it to start empty. And we should define also some additional include paths back on the other project. For the directories, we can go to our QWT test to see what we did there. So we just copy this, since we put it into relatively the same position. This should be for all. Okay. Directories, then linker input. This also is needed. Zack. In principle, you could of course just change here the paths and then keep the two projects a bit more separate. And then QWT. We'll just include all those thingies because we'll need them. Data plot. Oops. Yeah, good. We will of course need more things, so let's grab them. We need scale is, I guess, good, and the zoomer is nice. Let's take this as well. And then plot. We don't need data, so zoom until this. Yeah, that looks like it's all that we need. Right, plugin column will be column 1. This we insert here. Main layout. Add widget. That will be this. We didn't make a new plot. That we will need. So here, comma, row null, column null, row span 2, column span 1. Because we have here added a few things, although we could even do it a bit smarter. Just go somewhere here. Then we could say that this will be the row count. because basically the amount of rows on the right hand side must be the amount of rows to merge on the left hand side, so that our plot takes all the space, and on the side you will only have the toolbar and the thingy. And if we add more elements there, then we want them to be added as well. So in principle, did we use this often? No, not really. So we'll just put here 1, and that's it. Okay, let's run it. Let's see if it builds fine. I forgot to build this. Okay, still building. Okay, let's run it. Well, that's how it looks. We could we should make this nicer, so we can limit the width of our tree. Plugin tree, set maximal width, I don't know, 200 maybe. So now this will always be 200. Yeah. We can of course then make this more complex, add more things. Also now the way it looks, I might maybe go here to add a bit more. If we comment this out, this will go back to the default 9, which in this case looks now a bit more nice. Yeah, so what we would probably want would be some global toolbar, where we would have the start stop buttons. Data panel, toolbar, plugin toolbar, main toolbar. And we will here want to add for on start, on stop. Before we add the other thing is here. My layout. Yeah. Add widget, comma row 0, column 0, row span 1, column span 2. But this also means we need to change a few other things. Row width should start at 1. Then there should need -1. And okay, row is at 1, so here we start also at 1. And then we add here, add action. Start, on start, stop, on stop. On start, on stop. Okay, let's see if we change the indices correct. Yeah, it looks still correct. So now we can start stop here. This will just go to the where's the plugin manager? Plugin manager, and just trigger. Actually, we could make this even more easy. We could directly connect to the plugin manager. We don't need to go through an own thing here. But that of course requires the thingy to be created before. So we created just somewhere at the very beginning. What was the start here? Then we just call it start and stop. And copy. Plugin manager. I don't like the name, maybe start measurement. Yeah, that sounds much more sciencey. Start management measurement. Could also have called it start plugins and stop plugins, I guess, but now we are at this name, so let's stick to it. There is a reason why we maybe not want this. Let's undo this more change, because we would like to be able to report back on an error if an error would have occurred or something. Int or in status plugin. No, that should be just I'm in the wrong thingy, and this also needs to be changed. Int return. Okay, for now we just return okay, but we'll change this in a second. Panel status plugin manager, start measurement, and of course here if is success. If is not success, then display error. Yeah. Status is success stop. Data panel on start and stop plugin manager. Right here. For each plugin, actually I can just copy this. Comma in plugins. Int status is equals plugin start, and if this is wrong, so if you started, then return if not is success. And that brings me to an idea. We should also add I think it wouldn't be necessarily a fatal error. Already stopped will be a positive error returned if we stop a plugin that is stopped, if the plugin even tracks its own status. And the other ones here, of course, we can copy this to stop. But we don't want to break, because if we last status so we don't want to break, because we want some ability to stop the thing even if one of the stops fails. I deleted too much. So this thing will always run, but it will set the last status to the error. Of course, if we have multiple plugins causing errors, then the thing will not behave ideally. It will then just give us one and the other ones will be suppressed. But as long as we have one arrow, that's the starting point. We could of course change this to like get the first one, but for now I think this is good enough. I think we are starting to run out of time, so we won't be finishing this and adding DLLs during this lecture. We can think about if we can find some other nice things to be done. It would be easy enough for the time remaining. I just call it start and stop. That's doesn't need to be so long. It's easier to type. We could make a few graphical improvements to the data panel. So currently we have like a fixed separation between the two elements, and this is not necessarily the most user-friendly approach. So let's create two panels. Center widget, center layout, right widget, right layout, left widget and left layout, widget and left layout, Q splitter, mpan main splitter, or let's call it H splitter, and oops, H splitter, and the second one V splitter. That should be of course a pointer. Cute. And then we will need some something for later. Q. Let's call it Q tab widget log tabs. This this will have quite a few things which might be missing. This and this. So let's add this to here. Stack. Alright, and there won't be any. Well, there will be. So we need to. Okay, we have this. That might be all. Let's start reworking it. So we have our main layout. We have our main toolbar, but we only just put it in 0, 0 for now. Right here. So first H v splitter splitter there's a what was the code? Oops, orientation, Qt orientation. Qt orientation, horizontal. No, we wanted the other one. Vertical. So a splitter is such a thing that you can move it around, and we'll have one on one side, one on the other side, and one from the bottom. Yeah, so this thingy and widget Log tabs, this will for now be empty. But it's nice to have some sort of log. And add tab. New get just an empty thingy with a label. Log. Actually, this could be a Q label. Q label which says to do. And widget. Okay. That will be our vSplitter. Then we have here our HSplitter. Horizontal vSplitter. Add widget HSplitter. Okay, now we need to do it correctly. Yeah, let's do it like this. Center widget is new. Center widget. Layout is new. Layout. We don't need to call set layout if we just give the widget to the layout as a parent. Then it kind of automatically does this for us. Okay. Splitter. Add widget. That's of course wrong. We need to maintain the order. So we start with the right. Actually, we could just move this here, and then we can just put them like this. Right widget, center widget, left widget. Good. So our center widget and our center layout will contain the plot. Rows I will comment that now. Will contain the plot. So and widget plot, and we don't add anything else. We just add the plot. Later we can add more things, and we might to make it more complex. But for now it's fine. Our right thingy will be completely empty. We don't have yet a job for it. And here we had the main layout here. Alright, we still need the row. Int row is equal to 0. Row. Okay, and this is it. Let's move row. That doesn't matter. Let's move it still. Let's move it to the beginning. It's a helper variable we might use more often. Okay. That should be it. Menu bar was in the center. Main layout. We forgot. We forgot something. We need to add our vSplitter to the main layout. Add widget. vSplitter, row 1, column 0. Yeah, okay, let's run it. Well, it looks like shit, but it works. We cannot pull it up because the label has a fixed height. We don't want to fix this, but we should do this for more of the things. So for the center layout, I guess. Yes, for the let's just set this for all layouts. Since it's free, it will then kind of still give a total of 6 with regard to the outer window borders. Zack. that does not look that much better. The left widgets. Minor mistake. It should be set on layout, not on the widget. Layout here. This one should be fine because spacing we don't need. I think this is by default small enough. Yeah, that looks better, but it still doesn't look nice. So let's go. Oops. For this one, let's go with just 1, 1, 1. Center. Oh, this there. One more fix, and it should be fine. Yeah, that looks nice. Good. And since we're almost out of time, if not quite entirely out of time, just a few things. You can collapse those thingies. You can also set a property to prevent this collapse behavior from occurring. If you want that a particular thing should always be there, because if you collapse it, then it's kind of a guesswork where to grab the thing correctly. Yeah, and of course it nicely resizes when it resizes everything. So during the and here we had set a limit somewhere, which now makes it look not so great. I think it was 200. Yeah, let's remove that and rerun it. Yeah, so now it works nicely. Of course, with a bit more elaborate modifications, one can change things such that when it starts at the default, it will start with a certain ratio between the different panels. The positions can also be saved and restored so that when you close and open the application, it will look the same. We can do the same, of course, for the position and size of the window itself. But since we only have 4 minutes left, I don't think we will be doing that. Yeah, so during the next lecture we will take a look on moving all those plugins into DLLs. So that will be a little bit more complicated. The thing when using when using a DLL is and Qt is that either you would make the DLLs completely independent from each other, in principle using their own copies of Qt, but this would be very complicated with regard to the interface, so you would only be able to have a very very basic interface between the two. You could not use any signal slots and stuff like that, or at least not easily. And it also would have the problem that if you load a library DLL, they are usually identified just by name. So if you would have like multiple instances of Qt which are not of the same version, but still have the same file names, then the whole thing would more or less fall apart. So you would not be able to load the plugin correctly if some of the details of the Qt implementation would have changed. So usually what one is doing here is just selecting one Qt version and then just using it across all the plugins and the main application, so that you just have the same version. And if at some point you change the Qt version, you just need to recompile all the plugins. So for your own use in some own application, this is good enough. But if you would be planning this to be deployed and used by different people, or having even third parties creating plugins for this, that would of course with Qt be a huge hindrance. So it would not be the best approach to do it, but it's on the other hand a very convenient way, since Qt gives you a lot of possibilities. You can just easily paste strings across, etc., etc. So we will be in one of the next lectures exploring how such things would be done if you want to really to have full separation, and then we will also take a look to what extent we can break our own project up into plugins, and what level of abstraction is for a simple application like what we are doing here reasonable, so that it does not make things too complicated. Any questions? No questions? Okay. Good. So if there are no questions, then we will stop for today and continue doing the next lecture. If you have any questions in the meantime, you can email me. I will stop the screen recording.